Hey, good day, everyone. So now we're going to talk about double angle identities. So as we talked about in the last video, these are the double angle identities that we're going to be playing with. And we're going to do a couple of problems that deal with double angle identities. So, I'm just going to refer back to these. I have them up on the screen right now, so I'm going to refer back to them as well. So definitely utilize note cards or notebook paper, something like that, to refer back to these because you're going to be using these formulas quite a bit, just like we did with the half angle formulas. So let's look at an example problem here. Actually, I'm going to do this one first. So given that your cosine value is equal to -3/5 and your angle is in the third quadrant, find the sine of two times your angle, cosine 2 times your angle, and tangent of 2 times your angle. All right, so it's going to be quite a few steps on this one. The very first thing we need to do on problems like these is draw your triangle. Okay, we always got to reference that triangle. So when we go and we draw our little triangle, that's going to be based off of this angle right here. The triangle is going to be in the third quadrant, so it's going to be down here. And if you remember, cosine is adjacent over hypotenuse. Remember, caught another hippie. Remember SOHCAHTOA? Some old hippie caught another hippie tripping on acid. Cosine is adjacent over hypotenuse. Your hypotenuse is always going to be positive and it's the bottom number. The adjacent is going to be the other guy, the -3. All right. So to figure out the missing value, that vertical side, well, if you know little tips and tricks, you can go ahead and do that. For me, I don't trust tips and tricks. I just do it old school. I'm old fashioned. But as long as we get the same answer, that's all that matters. So we can do the Pythagorean theorem. So that's a squared plus 9 equals 25. Subtract 9 on both sides. So your a is 4. Okay. Now, yeah, I said 4, but it's actually a -4. Why? Because of the reference. That vertical side is below the x-axis. So that means all your y values are negative. All right. So yeah, even though it is a +4, because it's below the y-axis, your value is a -4. All right. Now we found all the missing pieces that we need to find. So now let's utilize those double angle formulas. So sine of 2a, okay, was 2 times sine of a times cosine of a. Okay. Now, a is your angle that we got from our from our triangle. All right. So let's go and figure out all the missing pieces. So it would be 2 times the sine of your angle. Okay. So the sine of your angle A is opposite over hypotenuse, which means -4/5. So that would be 2 times -4/5. And then cosine of your angle. Well, cosine of your angle is adjacent over hypotenuse, but it's also given us in the triangle. I'm sorry, it's also given the triangle, but it's also given us in the original problem. -3/5. All right, so we did the trick. Now we get to do the algebra. So we multiply straight across. So 2 times -4 is -8. -8 times -3 is +24. Over 1 times 5 is 5, times 5 is 25. And that right there is the value of sine 2a. Okay, that's your double angle value for sine. Pretty straightforward. Cosine will work something similar. Okay, I'm going to utilize the 1 minus 2 sine squared a. Okay, the reason why I'm doing that is because, well, actually, no, I'm going to do the cosine way. Because the reason why I'm doing that is because I'm given a cosine value. Okay, if for some reason my triangle is incorrect, if I use the cosine is given us in the problem. But if I use sine, there's a chance it could be incorrect because I'm basing it off of the triangle that I drew. All right. So really, and I have my old trig teacher talking to me on this one. Use what you're given because that reduces the risk of any kind of errors that you make. Okay, if you use stuff that you create, you're starting to increase the risk of making mistakes. Okay. So on this one, I'm going to utilize the double angle identity for cosine. So that would be 2 times the cosine squared of A minus 1, which is not the way I originally did it. I actually used the 1 minus 2 sine squared. Okay, and I should get the same answer. All right, so that means it would be 2 times the cosine value that we were given was -3/5. So that means that would be -3/5 squared, and then minus 1. So really on this one, we're going to be doing a lot of orders of operations, so a lot of algebra. Knocked out the trig, so we get to do the algebra. Remember your orders of operations. Exponents come before multiplication, which come before subtraction. Please excuse my dear Aunt Sally. So what that means, it would be 2 times -3/5 times -3/5 would be a positive 9/25. Basically, that square gets applied to the top and it gets applied to the bottom. And then minus 1. So we took care of the exponents. Now we got to take care of the multiplication. So that means that would be 2 times 9, which would be 18/25, and then minus 1. Now we get to add and subtract fractions. So 18/25 minus 1, which is 18/25 minus 25/25. Remember, least common denominator. That would get us a -7/25 for our final answer for the double angle cosine identity. Okay. So, you know what? Most of the stuff is just the algebra. You just got to know what formula to use. Now let's take a look at the tangent one. So I'm going to do the tangent one over here. So the tangent, okay, is a little bit more complicated, but we have to reference the triangle that we drew. Okay, we don't have a choice on this one. So the tangent of 2a is equal to 2 times the tangent value over 1 minus tangent squared of your value. Okay. Now, remember, tangent is opposite over adjacent, tripping on acid. Don't forget that. So what that means is that would be 2 times tangent of your angle, which would be -4/3, which -4 over -3 would be +4/3. That's why tangent is positive in the third quadrant. So it would be 2 times 4/3 on the top over 1 minus, excuse me, tangent squared of your angle. Well, we don't have to go out and find the angle because we just found it. 4/3 squared. Okay, just did the trig. Now we get to do the algebra. So on the top, 2 times 4/3 would be 8/3. On the bottom, it would be 1 minus. I'm going to take care of the exponents first. So that would be 1 minus 4 squared, which is 16, over 3 squared, which is 9. All right, so we have a messy looking fraction right here. Very messy. Well, let's clean this up. That would be 8/3 on top over 1 minus 16/9, because we're starting to run out of room. That would be 9/9 minus 16/9, because we got to find the least common denominator. So that means on the bottom, that would be -7/9. And when we add and subtract with the fractions and the whole numbers. So now we have a fraction divided by a fraction. Remember, Man, I feel like a broken record on this one. Keep, change, flip. So that means that would be 8/3 times a negative 9/7. All right. So here, the 3 reduces out. The 9 reduces to a 3. So that means I would have a negative 24/7 for my double angle formula for tangent. Okay. The hardest part about these is not the trig, but the algebra. All right. My tablet is really wanting me to do a software update today. I don't know why. All right. Now let's take a look at another double angle problem. Okay, this one might be a little bit more complicated just because it's a negative angle, or it's a negative value, it's in the fourth quadrant, but we're using the same processes. All right, so given that your angle, your sine value is a negative 7/25, and it's in the fourth quadrant because sine is negative in the fourth quadrant, find your sine of 2a, like your double angle for sine, double angle for cosine, and double angle for tangent. So hit pause real quick, refer back to the other part of this video, because we're going to be doing the same steps. Okay? So hit pause real quick. I'll give you a second and then we'll get on this. All right. So first things first, got to draw a triangle. Reason why is because in all of these double angle formulas, we're using all the other trig functions. All right. So the angle is in the fourth quadrant. And the sine is negative 7/25, which means your opposite side is a negative 7. Your hypotenuse is 25. And always got to make sure, okay, we got a 90-degree angle. Okay. So to figure out the missing value, we do the Pythagorean theorem. See, this is why I didn't like those tricks earlier, is because the tricks really don't work on, other like triangles other than like 3, 4, 5, and things like that. So that's why it's very good and very good to be familiar with the Pythagorean theorem. So that would be negative 7 squared plus b squared equals 25 squared. Okay. So that means that would be 49 plus b squared equals 625, if my math is right. Let me double check that. Yeah, 625. All right. So when we subtract 49 on both sides, we get b squared, which is 576. And if my memory is right, let me make sure that. Yes. The square root of 576 would be 24. All right. Now, it's a positive 24 because we're over on the right side of the y value, of the y-axis. The right of the y-axis, your x values are positive. So keep that in mind. All right. Now that we have all three sides of our triangle, we can find all the double angle values for our trigonometric functions. So sine of 2a is 2 sine A cosine A. Now, that means that would be 2 times the sine of our angle in our problem, or the triangle, whichever one you want to use. I'm going to use the one that's given in the problem. So that would be 2 times a negative 7/25 times the cosine value, which I have to go to my triangle for. So that would be times adjacent over hypotenuse, which is 25. That's gonna be a funky number. It really is, but it's okay then. Just because it's a funky number does not mean it's wrong. So don't second guess yourself on that one. So 2 times negative 7 times 24 would be a negative 336 on top. And then on the bottom, 25 times 25 would be 625. Mine wants to write 25. 625. There we go. So negative 336 over 625 would be the double angle value for sine. For cosine, since we're given sine, let's use the 1 minus 2 sine squared theta, or sine squared a. So 1 minus 2 times sine squared a. And the reason why I'm choosing that one, like I said, even earlier in this formula, or even earlier in this video, is that I'm given the sine value, so I'm going to work off of what I'm given first. So that means that would be 1 minus 2 times the sine squared of your angle. So the sine of our angle that we were given is a negative 7 over 25, and then we square it. All right. So remember, orders of operations. Exponents come before multiplication, come before addition, subtraction. So that means that would be 1 minus 2 times negative 7 squared would be a positive 49. 25 squared would be a 625. All right, so we took care of the exponents. Now we get to take care of the multiplication. So that would be 1 minus, and then 2 times 49 would be 98 over 625. All right, even though it's a messy fraction, it's still not wrong. So now we got to find the least common denominator and then add and subtract. So the LCD would be 625. So that means that would be 625 over 625 minus 98 over 625. So 625 minus 98 is 527 over 625. Funky fraction, but it's still legitimate. It still works. For double angle formulas, for half angle formulas, there are going to be many times when you get some weird looking numbers. Okay, it does happen. All right. Now let's look at the tangent one. So tangent of 2a, tangent of 2a is 2 times tangent of a over 1 minus tangent squared of a. All right. So that means that would be 2 times the tangent of our angle, which is a negative 7 over 24. Over 1 minus tangent squared of a. So our angle, or our tangent value, is already negative 7 over 24. We just got to square it. All right. So yeah, we just did the algebra. Or, I'm sorry, we just did the trig. Now we get to do the algebra. So that would be negative 14 over 24 on top over 1 minus negative, oh, no, not negative. 1 minus 49 over 576 on the bottom. Yeah, yep, there's some funky numbers again. So negative 14 over 24 divided by, now the bottom, we got to find the least common denominator. 576 over 576 minus 49 over 576. So that means that would be negative 14 over 24 on top over 527 over 576 on the bottom. Still not done yet. Because we have a fraction divided by a fraction, keep, change, flip it. So that means that would be negative 14 over 24 times 576 over 527. Okay. Now, I don't have this problem written down on purpose. Okay, I did that on purpose because 576 and 24, at least they're both even numbers. So they're both even numbers. You can divide them both by 2. So 576 divided by 2. That'd be 288. 24 divided by 2 will get us 12. All right. Now, 288 and 12 are still even numbers. So we can keep dividing those by 2. That'd be 144 and 6. See where I'm going with this? You could divide it by larger numbers. Yet again, same process. They're still even numbers. So 144 divided by 2 is 72. 6 divided by 2 gets us 3. So that means we would have negative 14 over 3 times 72 over 527. All right. Hey, guess what? Yeah, they're not even numbers, but 3 and 72 can go into each other. 3 goes into 3 only one time. 72 divided by 3 gets us 24. Yep. So, line reducing. So we have negative 14 over 1 times 24 over 527. So we can't reduce this any further. So now we can just multiply straight across. So that would be a negative 336 on top over 527 on the bottom. All right. That process, or that number right there, is a whole lot easier to reduce than if you would have multiplied straight across on the top at the original problem here. Okay, we would have gotten, I'm just doing chicken scratch here, 8064 over 12,648. Okay, now those would have been some big numbers to reduce, and you can keep reducing those and you still ended up with the same answer. Okay, but we just did it a little differently. I just kept dividing the numbers by 2 and then divide the numbers by 3 until I couldn't do it anymore. That way I can deal with smaller numbers. All right, I like dealing with smaller numbers. I know a lot of people do, some people don't. But a lot of this problem, like I said on previous problems, is the algebra. That's where the hard part is. So as long as you keep up with the algebra stuff, you can knock these problems out of the park. All right. So as always, guys, let me know if you have any questions. I'm happy to help. Hopefully these videos do help out. Let me know if y'all come across some problems, and I would be more than happy to make another video for you. All right. So have an awesome day. Take care. Let me know if I can do anything to help you guys.